We have a MacBook Pro. This is a 16 inches, and it's no power. So, mm, okay. As you know, with no power devices, we are not going to put power to it until we confirm what state the device is in. So, first thing we're going to do, we are using a pendulum screwdriver to take out the back screws. This is a 16 inches. It's an Intel device. It looks fairly clean inside. The board number for this is going to be 820-001-700. The board number you can find here. I'm not sure if you guys can capture that. So it's 820-001-700.
Yeah.
So that's the board number. So the first thing we do once we take out the back cover is to disconnect the battery, and then we also want to quickly see if we have a short on PPBUS. Um, so with the 16 inches, when you're troubleshooting the 16 inches, there are two sections, or there are two regions you want to quickly check for a short. So I'm going to open up the board view to show you guys on the board view and also on the board. Now on the board view, what you want to do is you want to check for on the board view, you want to check for a short on your PPBUS line, and that you can find on the fuses. So you can either use your F7000 and F7001 are fuses that are sitting on your PPBUS rail. You see there where it says PPBUS underscore G3H. Now G3H will mean that that's a rail that is always present, provided you have any type of power source, whether it's a battery or your charger. Now, uh, um, once your back cover is out, the battery is disconnected, the BMU cable, the battery and management cable is disconnected. You want to check if you have a short on your PPBUS rail. Now, after you've checked that, the next rail you want to check is you want to check these two guys here. So these two cap here, this and that, you want to check if you have a short on either of this cap here. So, and that is going to be, those two caps are going to sit on the 2.5 volt NAND. So the reason why that is this. So um, I'm just gonna switch. So sometimes you may not have a problem. You may not have a short on your PPBus rail, but you have a short on your 2.5 volt rail. And usually, when that is the case, it's the case of a failed cap and not the actual NAND chip. But sometimes you do find a situation where you have a short on a 2.5 volt line, and it's actually because of a NAND chip. So the battery cable has been disconnected, which then means that we are no longer getting power from our battery onto our board. So we want to first of all want to see if we have a short on our PPBus. So we're going to use a very loud multimeter. We are setting our multimeter to continuity mode. Need to replace that battery. Remind me so we can get a battery for that. Okay, so my probes, I'm having my black probe is going to go to ground. I can use my SSD, the top of my SSD as ground, or I can use a screw hole, which is that as my ground. So just to confirm that my continuity is active, that's it. So I get a beep, so I'm going to put my black probe on ground and then my red probe to my fuse. And we have a short. So let's hope that our short is not coming from the NAND, because that's a common failure on the 16 inches. As you guys know, that the repair that we actually completed over the weekend, that was also a failed NAND. U9080 died, and then it killed one of the NAND, U8600. Um, yeah, so let me just confirm that it's not U8600. Yes, UT600. Yeah, that's what it was. Okay, so we have a short on our PPBus. We are now going to take out the screws to find out where the short is coming from. So usually I would use my T5 first, and then then my T4. But today I'm just going to start using my T4 first before I move on to my T5. Okay, now I'm going to switch to my P5. Remember the screw that goes there and that? These are the same size. And the battery screw is always longer than the 13 inches and the 15 inches. Okay, now I'm going to use my T7 or T8. Okay, screws are out. Now let's take the board out. It's always best if you can use your fingers, but if you cannot, you can use a tool. Just make sure that your tool is not handed complete control. Okay, screws are out. Now we have to take the board out. Okay, let's put the shell on the side. And we found our board. So we are going to do a general inspection on the board, see if anything has failed. So usually I want to look at around our U9080 here to see if a component, if U9080 has failed, but this looks great. It doesn't look like U9080 has failed. And then I'm also hoping that none of our NAND chip has been damaged, which is creating a short on our PPBUS. And then another thing I also wanted to check again is just to check. Sometimes you may have your trackpad actually creating a short, but that's very rare. That's in the case where you have liquid damage, and then there was a bound, you have a surge on your on the PPBUS. PPBUS line on the trackpad. So this is your trackpad connector. So usually you will have an issue on, so is that a track? No, no, that's not the trackpad connector. This guy here, that's going to be the trackpad connector, yeah. And then you have an issue on 33 and above. You have, so 33, you have an issue here 33, 35, 37, 39. That's a PPBUS. So you have a case where there's liquid there, and because of the high voltage line on that, and then it bounds out, and so usually it damages the trackpad cable, so you have to replace the trackpad as well as the trackpad connector. But that's not the case here. But just again, let's just confirm again that our short is still there. Red probe on our fuse, and we still have a short. Okay, so on this side, we don't see anything that stands out. So we're now going to flip the board to the other side to see if anything stands out. So usually I'll start from my right and then I'll move to my left. Okay, so I think I see something. So you see that those two, those are oxidation. That's not liquid, those are oxidation. So those are, let's see what those two capacitors are, this guy here and that guy. So if those are PPBUS, if those are sitting on your PPBUS line, so you most likely, this might most likely be our issue. Let's see, what are those? Yeah, so those are sitting in PPBUS line. However, those are going to come after R5620. So as you see, it says PPBUS underscore G3 hot underscore SSDO. So that's not that's a sub rail of your PPBUS. So we are going to remove C9581 and C9580, and then we really hope that that is our problem. That would be great if that's our problem, so we don't have to do so much on this. So what we are going to do is we're just going to yank the cap off, and then the other one do the same thing. So the reason why I'm doing that is I don't want to put so much heat in that region because of our nine chip. So the two caps that are looking not looking too good. Now the way this work, yeah. So your capacitors, I'm just going to explain something. So this is your cap here, yes. Now you see how it says pin 2 is your ground, correct? And then pin 1 is the main line. The main line is what it's connected to your PPBus line, correct? Now that sub rail, it's part of the main PPBus rail through R5620. Now the way the capacitor it's designed is such that you have a part of it connected to ground, and then another part of it connected to a line, and then you have an insulation material in between. Now this part now basically prevents pin 2 from being equal to pin 1. However, when the capacitor fails, pin 1 will then become equal to pin 2. What that means is PPBus underscore G3 hot will now be equal to ground. Ground will be equal to PPBus, which would mean that whatever this is connected to will assume that is also connected to ground. So with C95, C95 80 and C95 81 outside the board, let's see if we still have a short. That would be great if we no longer have a short and we don't have to do so much on this board. Alhamdulillah, it's beautiful. Short is gone. Okay, so those are the problem that you are having, and then as you guys can see, the shorts are gone. So what we are now going to do is now. By the way, you may wonder. So that is very common in terms of that type of failure. So what happens? It's so if you see this side now, this the vent here, so you have a buildup of dust and moisture. So and then also because that it's a high voltage line, it tend to basically attract corrosion. So that's how it feels, and yeah, alhamdulillah. And then this is also another good thing why it is not okay to connect power to your board until you're sure what state the board is. Imagine if we had connected power to it, most likely let's see, the U9580 would have burned out because of the short, and then when that burns out, it's then going to send 2.5 volt to your SSD as well. Let's see, the 2.5 volt line, so it's then going to send you 2.5 volts to a line that is supposed to get, sorry, it will send out 12.6 to a line that's supposed to get 2.5 volts. So we are going to clean that out, replace the two capacitors, and yeah, and then that will be the end of the repair. So let's quickly replace those two cap. Shine, is it making sense? Mm, yeah, it's yeah. It depends. It depends. Yeah, sometimes it might be better not to put it back. Yeah, but depending. Yeah, but this we should put it back. Okay, let's trim it out. See, that is also not looking good, so it's better we replace it while we are here. That it's not looking good. It's better to replace it while we are here. Okay, we're also going to remove. So while you're here, be careful not to hit a 9 chip. Let's replace that. Okay. We're now going to clean the board and also need to buy more tinners. This two also not looking good. I think it would be better to replace. And also this guy here as well. So these are caps that are. Let's replace those two. Although those are not immediately a threat now, but they might be in the near future. So best to replace them. Come on in. How is it? What's how are you? I'm good. You need something? Can I help you, Baba? Talk to me, boss. Yeah. What's up? Not a problem. Okay. Let's quickly clean the board. Okay, we can confirm that our short is normal. Black Pro 1 ground and an red Pro. As you guys can see, we no longer have a short on our PPBUS. That's good. So the next we want to do is we want to see if we now have a functioning board. Sometimes you might have a problem like this might result in your board getting stuck on recovery. That's okay. It's not a problem. You just need to revive it. So when it comes to using your DFU mode, using your Apple Configurator 2, there are two options available to you. You can choose to restore the device, but when you do so, all of the files will be lost. But when you revive, the files will still stay. I mean, the client's files will stay. So sometimes you may have a problem. I've actually had a problem like so. I actually had a situation where another company did the repair, and they had like a short around your nine chip, and then after they resolved the short, but they came back and said, okay, the device is still not going on. So what would happen is the trackpad, you get feedback on the trackpad, but that's about it because the device is stuck on recovery. So you need to hook the device to your secondary machine, go to your Apple Configurator 2, which is this guy here, this guy, and then you want to revive the device. So what will happen in that case is when you connect now, and by the way, so what that will mean is immediately you connect your the device to your Ethernet to your machine, it should pop up already in recovery. If it's not already in recovery, then that's going to be like a bit of a separate issue. So it has to already be in recovery. So I actually had an issue like that one. So yeah, so that's something you want to also look out for in case you walk around your SSD and the short is resolved, but the device still doesn't start. You want to hook the device up to your secondary machine and see if the device is stuck on recovery before you move further. The more you take out, the more they fall back in. Yeah, so you just have to take it easy, not to, so you don't break anything. Boss, you know where, yes? Yeah. Did you see the milk there? Oh, yeah, you can check the fridge for milk. Okay, so we are gonna connect the cables. We yet to test the device. So ideally, we could just connect some of the cables that we require for testing, but yeah, so that if it doesn't work, you don't have to, you don't have so much cables to disconnect. But let's just hope that it's going to work. So we are going to connect all the cables. It's there in the white container. No, no, on the floor. Yeah, right in front of you. Yes.
Yeah.
Thank you, sir. Okay, so put a battery screw to it, and the screen cable. Okay, now we can connect charger to it. We have trackpad feedback. We have trackpad feedback. Let's watch out for the fan. So the way this is going to behave, it's the fan would at least, that's a good thing, and then stop. It's not going to continue all the way, and that's a beautiful Apple logo. So we're not really going to wait for the device to boot. So yeah, we are okay. For some reason is in recovery. Hmm. Well, that's fine. We are not really going to worry about that. So this is a completed repair. So we're going to quickly put the device back together. So all of the screws are already, all of the cables are in place. We are now going to quickly put the screws back.
It shows that that means this.
No, 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 no. If it's in recovery, it will not start at all.
Okay.
Yeah. So, so what would happen is the device will be stuck in recovery mode, and you can only see it that is in recovery on a secondary machine. On the machine itself, you won't see nothing. It will appear as if the device is dead, but you will get feedback on the trackpad. If I get it two long ones, not so long, but this is slightly longer than the other ones. And the ones that are very flat are the ones that will go on there. It's important you take note of your screw sizes. Make sure that you put the right screws where they're supposed to be. You have to remember the same screws that go here, the same screw sizes that go there. I see that sometimes when you put your machine together, you don't snap the sides in place. You don't snap the sides in place when you put your machine together. Sometimes you find that the sides are raised. Okay, that's done. So a brief summary. We had a short on our PPBUS, and we took the board out, narrowed down where the short is coming from. We found that the short was coming from C9581 and C9580, and that's and then we were getting the short on our PPBUS because of C9580 and 81 are connected as they are connected as a sub rail on our PPBUS through R56 20, which is a current sensor resistor. If you were to remove that, we would have been able to isolate the short. But we found that the two are a bit corroded. We removed both those, and then the problem was solved, and then we then replaced them. Now we also did replace C9588, but that wasn't because it's actively an issue, but because it might be an issue in future. We also replaced C9532 and C9531. And yeah, as you guys can see, the machine is now powering on. That is going to be done by the company. It's not something that we're going to get involved in. Thank you guys. I will see you guys in the next one.